Okay, this is section 9.3 in your textbook of MathLinks grade 9. It's on inequalities, and the variations of this particular chapter that was different than 9.2 is that we have two-step inequalities where you have a constant and a coefficient, or in some of these questions you also have variables on both sides or distributed property. So the skills you learned in chapter 8 on algebra just apply here. The only difference is in chapter 8 on equalities you had one value for x, and in chapter 9 you have infinite values for x, and there's a range between this number and infinity for a lot of them. So with question 3a, it says 5x minus 19 is less than 36. So what value can x be so that when I substitute the value of x in there, the expression 5x minus 19 will be less than 36? So obviously there are more than one value, and in order to determine what they are, I isolate using my opposite operation, keeping my inequality like that. I get 5x equals 55, divide by 5, and any value that's less than 11 will be a value you can substitute in for x, and it will make this expression 5x minus 19. As long as the x value is less than 11, that expression will always have a value less than 36. In the second example, get rid of your constant first. 2x is greater than negative 40. Divide by 2 and divide by 2. Any value that's greater than negative 20 will allow this expression to be greater than negative 13. Okay? And we could check that. We could say, well, let's just check a value. Let's say, well, what's a value that's greater than negative 20? Well, 0, if x was 0, 0 is greater than negative 20. So if I was to substitute 0 here, I'd have 27 plus 2 times 0, which is 0. That would make it 27. And 27 is greater than 13. So therefore, 0 is one acceptable value for x. 1, 2, 3 are also acceptable values. So is negative 19. Negative 19 is a value that can also work when I substitute it. And finally, question C. The value of 3 is less than or equal to x divided by 5 minus 7. What I would recommend you do when you do these types of questions is your algebraic expression is now on the right, which is different than most of them. And what I would do is I'd start with that and I'd read it, what number divided, or any x divided by 5 minus 7. And since I said that and the sign is going this way, I would say x divided by 5 minus 7 is greater than or equal to 3. So all I do is I just read it backwards, keeping in mind that if I read the x divided by 5 minus 7 and the inequality sign is consuming or eating the expression I just read, then I read it as greater than. So I'm going to isolate the variable by adding 7. 10 is less than or equal to a fifth of x. I'm going to multiply both sides by 5. And 50 is less than or equal to x, or a better way to read it is x is greater than or equal to 50. Just read it backwards. X is greater than or equal to 50, and you can rewrite it if you want. So any value that is greater than or equal to 50 will make this inequality true. Question 4, variations here, nothing significant. I'll do them real quick for you. Subtract 92 from both sides. Negative 5y is greater than or equal to negative 52. Is that right? Divide by negative 5. And y is greater than or equal to negative or positive 10.4. Any value that's greater than or equal to 10.4. Oh, I didn't flip the sign. Oh, my heavens to Betsy. Thank you for reminding me. I have to flip the sign because I divided by a negative quantity, so therefore I have to flip my sign. Otherwise, if you don't flip your sign when you multiply or divide by a negative quantity, your inequality will be wrong. See, even teachers make mistakes, and we're almost infallible. Get rid of your constant by subtracting 10.6 from both sides. 4y is less than 8.4 negatives. Divide both sides by 4. Y is less than negative 2.1. Any value that you make less than 2.1 will allow, or negative 2.1 will allow this inequality to be true. And finally, add 2 to both sides. Y divided by negative 6 is less than 18. Multiply both sides by negative 6. Oh, that's not finally. And because you multiplied or divided by negative 6, you have to keep your inequality sign flipped. So instead of being y is less than, we have to say y is greater than. Negative 60 and 48 is negative 108. So any value greater than negative 108 will make this inequality true. And finally, the last one, which is your more complicated one. What I would do first is I would rewrite it myself. And I would change this to 54 over 5. Actually, what I'm going to do is I'm going to do it 2 different ways. So I'm going to take this again. I'll clone it. Bring it over here. I'll show you 2 ways. So the first way is whenever you identify any equalities, hope, or inequalities that have fractions in them, you learn that you can multiply both sides. So if I think of this as a scale, multiply both sides by a common multiple of the denominator. And when you multiply a fraction by a multiple of its denominator, it ceases to be a fraction anymore. So my denominators here are 2, 5, and really the 6 has a unwritten denominator of 1. So if I was to look at the multiples of all those, I would find that 10 is the first multiple they share. So if I multiply both sides by 10, I will maintain the required inequality. This is not an equality. This is for equalities, but this is an inequality. And if I multiply this side by 10, each of these terms is multiplied by 10. Which will mean I will have 15x plus 60 is less than or equal to 108. And once I get that, isolate as you normally would. And x is less than or equal to 48 divided by 15, which is 3.2. So any value that is less than or equal to 3.2 will make this inequality true. Now that's a lot of work. If you did it this way instead of multiplying both sides by 10, you could just do the standard, subtract the coefficient from both sides or get rid of the coefficient by making a 0 pair. You get 1.5x, or 3/2 of x, is less than or equal to, and this one's not as hard as it normally is, because 10 4/5 take away 6 is simply 4 4/5. Now I'm going to divide both sides by 3/2 to isolate for x. 24/5 multiplied by the reciprocal of 3/2. Cross reduce, 8/1 will give me 16/5, which is 3 1/5, which if I think of it as a decimal, is 3.2. Verify that x is greater than 8 is the correct solution in the inequality. So all we can do here is just take this inequality and solve it. X is greater than or equal to 8. Is this the same thing? Yes, it is, and therefore that's the correct verification. That x is any value greater than or equal to 8 is the correct solution to this inequality. In the second one, verify that this is the correct solution. I'm going to isolate. And of course, the trick is because you are dividing by -5, you have to take your sign and flip it. And you get all values less than -3, which therefore is the correct solution. Question 6, solve the inequality and verify the solution. So solve the inequality. So in this particular inequality, we have variables on this side and we have variables on this side. So just like chapter 8, When you do have variables on both sides, its first step is not get rid of the constant or the coefficient, but rather get rid of variables from one side by creating an algebraic zero pair. And the easiest one to get rid of is the one that has the least amount, which leaves me with 5x is less than 30, divide by 5, and x will be less than 6. So if I want to verify my solution, any value less than 6 means that my set of numbers can be whole numbers, would be 5, 4, 3, dot, 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 to infinity. Right? That's the set of numbers, whole numbers, that will work when I substitute in. So I can take any of those numbers, I'll choose 5, and I'll substitute it in to my solution. And this is 35 is less than 40. And since 35 is less than 40, that number, the largest whole number that is less than 6 works. And if I actually put the number 6 in there, which would be the first whole number that shouldn't work, I would get 42 here, and I would get 42 here, and 42 is not less than 42, so 6 would be a whole number that definitely doesn't work. So my solution seems valid. Again, we have variables on both sides, and some people say, well, if I subtract 8x from both sides, it looks like it shouldn't work, because what I end up with is 2x minus 22 is greater than or equal to nothing. And that's okay if you did that. So if you did that, you just started to isolate by adding 22. You get 2x is greater than or equal to 22. You divide by 2, and x will be any number greater than or equal to 11. So the set of numbers that x can be 11 itself, or anything greater, which is 12, 13, etc. to infinity. Okay? Now, if you subtracted 10x from both sides, that's also acceptable. So if you subtracted 10x from here and 10x from here, you got negative 22 is greater than or equal to negative 2x. Divide both sides by negative 2, and x has to be, flip the sign, so greater than or equal to 11. So any value that's 11 or greater, which was the same set of numbers we had before. The only difference is because you were dividing by negative 2, you had to flip your sign. C, negative 12x plus 10 is greater than. So the one I have the least amount on is 12x, so I'm going to add 12x to both sides. 10 is greater than 19 plus 8x. Subtract 19. Negative 9 is greater than 8x. Divide by 8. X is less than negative 1 and 1/8. Any value less than negative 1 and 1/8. And finally, your last one. If you have distributed property, you should expand it first. So I'm going to expand the distributed property. I get half of x plus 5 over 2 is greater than 22. Now, instead of saying 5 over 2, you could actually change that to, if you wanted to, a decimal, 2.5. And instead of saying half of x, you could say half of x. Put it down to decimals, which is easier than fractions. Subtract 2.5 from both sides. 0.5x is greater than 19.5. Divide by a half, which is the same thing as multiplying or dividing by 2. No, it's not. It's like multiplying by 2. So x will be greater than 39, because 19.5 divided by 0.5 is 39. So any value that's greater than 39 will keep that inequality true.